Ever pondered about the importance of resistors in electronic circuits? Imagine a highway with no speed limits. Chaos, right? That's how an electronic circuit would behave without resistors. They are the traffic cops of the electronic world, controlling the flow of electrons, ensuring that they don't speed or overcrowd. The humble resistor, a fundamental component in electronics, is the unsung hero that keeps our electronic devices running smoothly. Resistors are made from materials with high resistivity, such as carbon, metal, or metal oxide films. The length, cross-sectional area, material, and temperature of the resistor determine its resistance. They come in many shapes and sizes, from through-hole resistors to surface mount ones, and even variable ones known as potentiometers. These little components follow a simple yet powerful law, Ohm's law. It states that the current flowing through a resistor is directly proportional to the voltage across it and inversely proportional to its resistance. In simpler terms, if you increase the voltage across a resistor, the current flowing through it will also increase, provided the resistance remains the same. Resistors also act as voltage dividers. By connecting resistors in series or parallel configurations, you can create circuits that provide a fraction of the input voltage at a specific point. This is particularly useful when you need to lower the voltage level for certain components of the circuit. Beyond voltage division, resistors also limit the current flowing through specific components in a circuit, such as LEDs or transistors. This prevents damage due to excessive current. By choosing the right resistor value, you can control how much current flows through these components. Resistors also have a hand in signal conditioning, shaping, and filtering. They work with capacitors to create RC circuits, which filter out high-frequency noise or shape signal waveforms. The resistance of a resistor typically changes with temperature. Most resistors have a positive temperature coefficient, meaning their resistance increases as the temperature rises. However, some resistors, made from certain metal alloys, exhibit a negative temperature coefficient, where their resistance decreases with temperature. Finally, it's crucial to consider a resistor's power rating, which is the amount of power they can dissipate without overheating and potentially failing. Using a resistor with a power rating lower than required can lead to overheating and damage. In summary, resistors are critical in controlling the flow of electrical current, adjusting voltage levels, shaping signals, and protecting components in electronic circuits. These versatile and vital components are indispensable in countless electronic devices and systems. Without resistors, the electronic world as we know it would simply not exist.